Hello there and welcome to the October 2020 exam. Here we're looking at question 4, the big vectors question for this paper. A lawn is modelled as a plane that contains the points L, M and N relative to a fixed point O. Determine a vector equation of the plane that models the lawn, giving your answer in the form R equals A plus lambda B plus lambda C. So effectively what we've got here is a plane with points L, M and N on it, and what we're looking for is to represent this plane using two vectors and a starting coordinate. So my starting coordinate I'm going to label as, I'm going to just choose L, because I could choose any of them, but I'm going to choose L. So it's going to be -2, -3, -1, plus lambda, lots of. Now, how do I get from L to M? This is one of my vectors that I need. How do I get from L to M? Well, if I look at the numbers, L to M, I need to go up 8. I need to go up 1 on the Y component, and I need to go up 1 on the Z component. So that'll be that part of the vector there. And the next vector will be to get from L to N. So -2 to 2, that'll be up 4. -3 to 0, that'll be up 3. And from -1 to 0, that'll be up 1. So there we are. This is the answer to question A then. It's apparently worth 3 marks. You probably get 1 mark for each part of your vector there. But yeah, it didn't take us too long to work that one out. Okay, let's move on to part B then. Part I says, show that, according to the model, the lawn is perpendicular to the vector 1, 2, -10. Now let me get up that little plane again, where we have L, M, and N. Now, if my plane is perpendicular to this line here, 1, 2, -10, then it must be the case that the line from L to M is perpendicular to it, and the line from L to N is perpendicular to it as well. And if two vectors are perpendicular, then what we can say about those two is that A dot B will equal 0. So I'll test it with LM first. So 8, 1, 1 dotted with 1, 2, -10 is going to equal 8 plus 2 -10 equals 0. Good, so that is perpendicular. So therefore perpendicular. And I need to test it with the other vector as well from L to N. So that's going to be 4, 3, 1 dotted with 1, 2, -10. So that's going to be 4 plus 6 -10, which will equal 0. So therefore again, perpendicular. So if you've got those two directions vectors being perpendicular to 1, 2, -10, the plane is perpendicular. The plane is perpendicular to 1, 2, -10. And now thinking about what they're probably going to do in the next part of the question, this here is now what we can refer to as our n vector, the normal vector. Moving on to part 2, hence determine a Cartesian equation of the plane that models the lawn. Now remember, a Cartesian equation is n1x plus n2y plus n3z equals d. Now we've just found out what the values of n1, n2 and n3 are. That's the vector that we've just shown as perpendicular to our plane. So it's going to be 1x plus 2y minus 10z equals d. Now we don't know what the value d is yet, but what we can do is to work out the value d, we can plug one of our coordinates into the left hand side, and that will give us our d value. So let's pick which coordinate we'd much rather plug in, L, M or N. I think N looks like the easiest coordinate, 2, 0, 0. So if I plug 2, 0, 0 in, 2 plus 0 plus 0 equals d, then it's clear that my value of d is 2. So therefore, the answer to the Cartesian equation of the plane is x plus 2y minus 10z equals 2. And there we are, that's the answer for the Cartesian equation of the plane. Moving on to part C now, there are two sets of posts in the lawn. there is a washing line between the two posts. The washing line is modelled as a straight line through the top of each of the posts, where coordinate P is -10, 8, 2, and coordinate Q is 6, 4, 3. Determine the vector equation of the line that models the washing line. Okay, well, the washing line is just going to be the starting coordinate, we'll call it -10, 8, 2, and then the vector to get from one side of the post to the other. So that's going to be going up 16, it's going to be going down 4, and it's going to be going up 1. So there we are, that's the answer for part C. The answer for part D states one limitation of the model is that washing lines generally sag, or they're generally not linear. So you'd write that down as your answer for part D. And then moving on to parts E and F, the point R lies on the washing line. Determine, according to the model, the shortest distance from the point R to the lawn, giving your answer in the nearest centimetre. So what this question here is testing is the distance from a point to a plane. So this is the coordinate 2, 5, 2.75. And there's actually a big formula in your formula booklet that will help you work out the shortest distance from a line to a plane. It goes something like this: n1 alpha plus n2 beta plus n3 gamma plus d modulus over the square root of n1 squared plus n2 squared plus n3 squared. So that's the shortest distance from a point to a line. If the point is represented by alpha, beta, gamma, so let me just check the, so no, it's minus d on the end there, minus d. Minus d. Okay, so let's substitute into the formula. So the n1, n2 and n3, let's just go back and have a look, was 1, 2, minus 10. So it's going to be 1 times the alpha part of the coordinate, which is 2, plus 2 lots of the beta part of the coordinate, which is 5, plus minus 10 times gamma, which is 2.75, minus d, and d was the value 2. Divide that by 1 squared plus 2 squared plus minus 10 squared, and you can type that all into your calculator and get 1.71 meters. 1.71 meters. So there we are, that's the answer for part E. Given the shortest distance from the point L is actually 1.5 meters, use your answer in part E to evaluate explaining your reasoning. Well, 1.71 is quite different to 1.5. We could even work out a percentage error here. If we do 1.71 minus 1.5 over 1.5, let's do that on the calculator now. Fraction button 1.71 minus 1.5 divided by the actual value, which is 1.5, then this is 14% off times 100 will be 14% off, which is quite inaccurate. I'd give it plus or minus 5% either way, but 14% off, that's quite a way off. So it's not very far, it's not a good model for the washing line. So there we are, that's the answer to question 4, 13 marks for that question there in total, so pretty big question there. Let's now move on to question 5.